Hi, I'm Steve. I work at a company called Balanced Payments. We do credit card stuff for marketplaces. We use Python, but I'm a Rubyist. I have a Ruby tattooed on me, so I'm moderately invested in the Ruby world. I actually have commit to Rails, but I've always been a fan of polyglot and doing multiple language things. And so this has naturally sort of led me to now working at a Python shop. I actually don't even write Python code there. My job title is philosopher in residence. And while there's always tons of silly job titles at any startup in Silicon Valley, this one is interesting because basically my job is to pay attention to where things are going and also think about where we should be going. So one of those things is we have a website and we use web technologies. We love HTTP. And so I am also working on standards so that we can have a better future of the web. And so I want to talk to you today a little bit about the way that I see computing going in general in the future, or the way that I would like to, and then also how that ties into the way that the web standards world is changing, and how that affects you all as programmers, because it is historically, if you have not wanted to get involved in web standards, it is changing to fix that because that is a problem. So that's sort of what I would like to talk to you about for this 45 minutes. You can get some slides if you want. There's a link down there to the slides originally, browsers eating the world. So I titled this talk Web Browsers Om Nom Nom because there's a blog post that was written by Mark Andreessen called Software Will Eat the World. And it sort of described how software is becoming an integral part of everything that we do, everything around us, and that's really, really important. So this was why they invested in GitHub, is because GitHub is where all our code lives. And as software takes over the world, they want to be positioned to know stuff about software. So I have this particular future of computing in mind that's kind of a little weird, and it involves not just software eating the world, but the web browser eating the operating system. And I think that this will be a net win for most people, and I think that it is slowly happening, and it may or may not fully happen. So I'm spreading the word about this idea so that hopefully someone else will actually help me build it. So I have three big sections. The first one is a little bit of why I think this stuff is important, and this relates later too, is that we have failed non-programmers in the work that we do. I want to talk about why that's happened. And I want to talk about the way that web standards are done now, and web standards have failed us as regular developers, so this is the connection there. And then how could web standards look tomorrow, and how are they starting to look tomorrow? And then talking about extending the browser forward and the way that that will all work. And a little teeny bit about Rails, which will be applicable to any framework that you are going to be using. I use Rails generically because it's what I'm most familiar with. So, okay. This is something that I wish that we would come to grips with a little more as an industry, and I think that we have completely failed non-programmers at their ability to use computers. That's a pretty big statement, so I should back it up. I had this conversation with Tom Dale, co-founder of Tilde and co-author of Ember.js, and he said this thing to me, and I kind of said, yeah, Tom, whatever, and I let it roll around in the back of my head, and then later I realized it was amazing. So the thing I think historians will miss is that a web browser represents the first time we can download arbitrary executable code and not worry about screwing things up. Tom Dale. So, for example, if I told you to download a random exe off of your computer and run it, you would laugh in my face, I hope, right? Because that's very dangerous. Very bad things can happen when you run random executable code off of the web. But this is what we do every time we hit a web page, right? JavaScript is Turing complete. So why do we run arbitrary exes off of every single web page we hit? Because JavaScript is also sandboxed and only has a certain limited amount of APIs, and so JavaScript could only screw up so much, right? I tweet incessantly about how much JavaScript annoys me, but that's really just visual glitches and web pages not working. That's not just spammed all of my contacts. That's not deleted all my files. That's not encrypted the contents of my hard drive and asking for bitcoins to unlock it. Which is an actual virus that's going around right now, if you haven't heard. Super bizarre. So so this is super interesting, and this is sort of this transition point that the web has been undergoing this identity crisis in the last couple years, whereas it was originally a way to share documents with people, and has now kind of accidentally turned into a universal application runtime, right? And those things are very, very different. But I think that we can actually continue to make that transition, and that it's okay. So to talk about that, I want to talk about this. This is an iPad. I didn't get an iPad until very recently, and I started playing it because of there's a game, like a music game, that I was better to play on an iPad than a phone because there's more space, right? So I'm tapping away, and I'm like, oh, I need an iPad. So I bought an iPad, and I started playing games on it, and then I realized if I was going to bother, spending a couple $100s on a thing to play a game, I probably should use it for other things too, right? Because that's sort of super exorbitant. So I was like, oh, people have said that reading on an iPad is really nice. So I started web browsing on my iPad, and then I basically started using my iPad for all computing tasks that were not coding. And I realized this at some point, that I did actually prefer to use iOS. And I am a deeply technical individual. I've been programming for 20 years, and I'm not that old. I've used tons of programming, languages and environments. I could tell you all sorts of random junk that nobody cares about computers. But even I would prefer to use iOS. And I was thinking about why this is, and I realized that's because basically iOS does away with all the computer stuff and puts forward the doing stuff in the interface. This also happens with Firefox. So if you notice, this is a Firefox running on Windows. But it's basically the same as the Firefox that I'm using to run this presentation, right? It's pretty much the same. And it's the same as Firefox on Mac. And so my family has always had computers around. One of my uncles is also a programmer / mechanical engineer, computer engineer. And so my family has used Macs forever. The first computer we ever had was an Apple, a Mac Plus. And have essentially been all Mac people for most of my life. And so at some point, my family asked me, hey, we're on a tight budget, but our computer broke, and we really need to buy a new one. Is there any way that you could get a Mac for less than $1,500? And at the time, that wasn't really true, and the budget was more like $500. There was a very big gap there. And so after thinking about it a while, I realized that my family did almost all of their work in Firefox at that point, and I said, hey, I'm going to build you a computer for $500. It's going to look a little weird, but just don't worry about it. And they said, okay. And I built them an Ubuntu box, and they were using Firefox still, and everything was okay. And they seamlessly transitioned because almost all of their usage, and this would be 2006, 2007, all of their usage was already in web browsers. They basically didn't do anything outside of the browser. I actually wouldn't run X at all if I didn't need a web browser to do all my graphical stuff. I do everything in the terminal. I'm the MUT, TMUX, IRSSI, everything's got to be curses, and then a web browser. So for me, that's my entry point into everything graphical, and it was for them too. And so this is when I first started appreciating the nature of this universal runtime, where every application can be gone through a browser. This is one of my other favorite stories about my family. So to say I was a stubborn child would be an understatement. And my family were farmers, so I was the one that was into all this computer stuff, and they just kind of tolerated it. This is a screenshot of Word 5.1 from way back in the day, running on an old Mac. And we used this computer a lot, and we had good uses for Word and typing things up and whatever. But then Word 6.1.1 came out, and me, being the good little budding technologist, was like, we need to upgrade immediately. There's so much cool stuff in Word 6. And so I installed it, and if you remember what Word 6 looked like, it looked like this, first of all, which is amazing. I love this graphic. Yeah, for the Power Macintosh. It looks mostly like this, is how Word 6 looks. I don't think this is actually technically Word 6, but this gives across the idea. There were all these new features and bells and whistles that frankly were not useful whatsoever. But because I was a little kid programmer, I was like, these new features are all awesome and amazing, and I can't wait to embed Excel spreadsheets into my whatever. And my mom made me downgrade back to this. And I was super mad at the time. And I like to joke that this is the only argument that I think that I truly lost. Like, my mom was definitely right from my childhood. And it's not, so the naive person would say it's because my mom is too stupid to understand complicated interfaces. That's totally, completely wrong. My mom has a low tolerance for bullshit. And like, this is about getting things done, and this is about a whole bunch of like extra feature bullshit that doesn't actually matter. And when you come to realize that this is true, you realize that most of the things that we add as programmers is actually more like this and less like that. We tend to get in the way of the users of our software more than not because we impose silly architecture or like artificial historical artifacts like file systems. Like, no one in the world, except for file systems developers, wants to think about file systems, right? Like, as I said, deeply technical. This machine is running Linux. If you had to tell me which like file system to put on this computer, I'd be like, I don't know, ext4, because it's the newest version of ext, and that's what I've been using forever, right? If you told me, like, what's the difference between ZFS and ext4, I'd be like, I don't care whatsoever, right? But one of the things that iOS does that really dramatically increases people's productivity is that it does away with the notion of the file system, right? Your things are like, your photos are all shared in the photo app, and your other apps have access to those. You don't have to like, I don't know if anybody remembers like back in the day of like pirating tons of music, which of course I did not do when I say this on recording. But in theory, I knew people who had pirated large quantities of music, and they would need to like meticulously hand put all of the albums with the art and like make sure the naming scheme was like, it's got to be like artist, album title, year, and it's like super, and then like the program would like read the file system, would drag all this stuff in. That's a massive waste of everyone's time, right? Nowadays you like drag the file into iTunes and it's like, cool, good to go, right? So I think that we get really obsessed with these kinds of like whiz-bang features, and that blinds us to the needs of actual people who don't care about the details. And that's what like the web is in many ways, is it's a universal application runtime that abstracts away a lot of the dumb computer things like file systems that people don't actually need to use to get stuff done. So I think we can do better. The other thing about this that's really amazing and that I love is that this is 100% nominally, unless we continue to allow Google to roughshod, like run over everything. This is like the web is something that is very human. It is not owned by a company. It is not like controlled by a particular corporate interest. The web is something that we have all built together for humanity that's like higher and better than all that stuff. So I hate the fact that I use iOS so often because it is controlled by Apple, which is like this close to being fascist, right? So that really bothers me. So I enjoy the fact that maybe we could build a web that has all the benefits of the closed source, proprietary, litigious Apple, but has all the benefits of being like for humans and humanity, as opposed to making the largest company even larger. So that's sort of the way that I think that we've failed as programmers to help people understand how computers work. So let me tell you about how web standards have failed you as a developer. If you're not familiar, is anybody familiar with the way that web standards actually work? How many people have ever looked into this process at all? Anyone? Cool, we got a couple people. Great, this is all, my slides are useful then. It would have been bad if you all said now. So this is how it works currently in the W3C or the WG or the IETF, et cetera. The browser vendor, and that's like Google, Apple, Mozilla, et cetera, they propose some sort of feature, right? So for the purposes of this example, I'll use CSS border radius as the example, right? So everybody was like taking way too long using images to build rounded edges on everything. So we're like, let's make a property in CSS that gives you round edges. And then as soon as we got it into browsers, we stopped building websites with rounded edges. But so the browser vendor actually proposes this feature. So someone at, I forget actually who made border radius, but let's just say that it was at Apple. Someone on the Safari team was like, hey, this image-based stuff for rounded corners is kind of dumb. Why don't we add a CSS property that introduces rounded images or rounded edges? So they hack this together in C++, or I don't know if Safari is in C++, but like Firefox is. So they hack it together in C++, and they figure out how it works, and then they do it with a vendor prefix, because that's the right way you're supposed to do things. They submit their specification to the W3C or the IETF or the WATWG or whatever standards body. Fun fact, standards bodies only matter because we all believe they matter. Like, you can go make your own standards body at any time, and it has just as much legitimacy as the W3C does, except for the fact that everyone believes the W3C is more legitimate than your standards organization. But there's no like actual power whatsoever. Anyway, so Apple would say, here's my dash Safari border radius thing. This is how it probably should work. And so other browser vendors will then take that initial draft of the specification. They'll implement their own version of border radius with their own prefix. Then they will proceed to argue about it on mailing lists for weeks to months to years on end. And fun fact, you know how browsers only support get and post in HTML forms, and everyone overrides that? That's actually because the HTML spec says that form elements can only have get and post in that attribute. And the only reason it hasn't been expanded is because in the last like 15 years, twice has someone sent a post to the mailing list being like, maybe we need to update the HTML spec to add arbitrary HTTP verbs. And then people were like, well, what about all these edge cases? And then no other emails ever happen. So you could change that if you wanted to, for example. But anyway, they argue sometimes for years about the way this should all work. And then there's some sort of consensus is reached. Yay, we have CSS border radiuses. You remove the prefix. Everyone implements the way that the standard is specified. It arrives to us as web developers, and then we use Sass and Compass to make it actually usable, right? So the problem is we implement a JavaScript wrapper to so one good example of this is jQuery, right? So the query selector framework was designed by the standards committee, and then John Resig wrote jQuery because it was terrible, right? And we all use jQuery because it's way better than the standard built-in stuff. And it abstracts over all the bugs, but nowadays that's not as true, it's just that it's better. So there's a big problem here, if you can't tell by my not thinly veiled sarcasm, and that's basically that this power structure is totally the wrong direction, right? The browser vendors don't write websites, they write C++ for browsers. They care about things like allocations and garbage collectors and memory management stuff, not whether or not CSS is a functional way to describe interfaces, which is a whole nother can of worms. And so they're making stuff by imagining what we want as developers. And now there's, obviously within certain organizations, there's some kind of feedback group, right? So at Google, the people who hack on Chrome talk to people who build websites. And it's not like they're totally ignorant, but a very small number of web developers are actually involved in creating new features for the web, which is kind of weird. So yeah, the cons are that the vendors don't build the sites. It takes forever. There is no feedback from web developers, generally speaking, and also you get really spotty support because some people build new stuff and some people don't, based on whether or not they want to support whatever, right? So if you've dealt with the video element in HTML5, you're going to see I'm already painting, talking about this. The fact that Google wanted to use WebM as the video codec for video, but it has patents. So Mozilla said no, but Google said they would buy the patents and give it to everyone for free, but Mozilla still said no. And Apple's like, hey, we put H.264 decoders in all of our machines, so we're using H.264. I don't fucking care what you're doing. And it just so the video element is basically unusable unless you want to transcode your video to 2 to 3 different formats and serve it up based on people's browsers. And you wonder why people still use Flash to serve video, right? So it can be a giant mess. So what would a web standard of tomorrow look like? What would be a better way to do this? Because as much as I knock on this process, it still does work, at least nominally, right? So this is how it should work, and this is not totally me speculating. This is how people in the standards community are talking about moving the standards process towards this, which of course means more standards. But basically, I'm going to hand wave this first part because I'm going to talk a little bit more about it later, but if you could build new features for the web platform in your browser in JavaScript, then web developers could say, hey, here is an implementation of CSS border radius. This is how it's going to work. And then once we decide what actually works for all of us, we could submit that to the W3C, and it would be specified appropriately. And then browsers could implement it natively afterwards that's faster. This totally inverts that structure where instead the features of the web are driven by us, the web developers, and the browser vendors don't have to like imagine what we want anymore, and they can also like focus on doing what they do well, which is implement things really freaking fast in really low-level languages. So yeah, so we do build websites, and the speed is not limited by the vendors of, like, and that in speed I mean like the standards process will be talked about by people instead of by companies, which tends to be slow. And then the last one is actually one of the cooler aspects. You get a polyfill on day one. So because it's prototyped in JavaScript first, we have a working implementation that runs in all browsers. So this means instead of you needing to like test to see if it's detected and then add in the thing, like you already have a thing built that does that, right? So people, the way that this works now, I'm not sure how familiar you are with browser polyfills, but basically when we get a new feature, people often try to implement that feature in JavaScript as much as possible, and then detect if you support that feature or not, and then like throw the shim in if you don't support it. And you'd need to write that polyfill. In this case, we already have one, and it's already built and already works because it's the one that the spec was decided from. So that's also super cool. The big downside of this is that browsers are currently not extensible in a way that supports this workflow. The idea of implementing a CSS property in JavaScript doesn't make any sense. So we're trying to change that. Surprise! Oh no, I've perfectly set up this scenario. If only there was someone that was trying to fix it, like all of us. OK, so extending web browsers. This is sort of the key point in getting this happening, and this is why the standards have not currently changed so far. So I'm going to talk about the content security policy header. How big is that on the screen? Is that OK? Oh, that's tiny. Web stuff. All my slides are in CSS and JavaScript and HTML, so LOL, it's super tiny. Anyway, in this example, the text does not super matter, but there's a header called content security policy that allows you to specify which domains you allow JavaScript to be run from. So in this case, it says content security policy default source self and ajax.googleapis.com. This is super cool because it means that if I'm super evil hacker and I inject some JavaScript from lol.yougothehacked.com into the page, the browser will not run any of that JavaScript because you've said that you only want JavaScript from these domains to be run. So this is super helpful and interesting and useful. This is a header that exists today and was recently standardized. So this is an example of a feature that could have been prototyped in JavaScript first. If you imagine a theoretical hook where you could add an event listener onto the fetch event of the page, so like the first thing when it gets fetched from the browser, you could then run arbitrary JavaScript and decide what to do. So excuse me, in this example, we take the URL and we check to see if the request origin is the same as the URL's origin, and if it isn't, then we prevent the network request from happening, and otherwise we let it pass. So this is like an example of arbitrary, complicated security policy that would be written in JavaScript if the browser would allow you to hook into that page load event appropriately. And so what we could have done if the browser was extensible, we could have started with this and then moved to this once we decided that this was something we actually wanted to do and that was useful. The reason I use the content security policy header, I'll talk about jQuery in a second. The reason I use CSP as this example here, first of all, is because it's easier to understand how this would get implemented on a page load event rather than on implementing a CSS rule, but also because the way the content security policy was standardized has some flaws, and so they're considering updating the standard, and so this might be the first standard that works according to the way I am proposing as opposed to the way it has always worked. So we'll see how that actually goes in the future. One example of this too, as I mentioned jQuery earlier, so if browsers were extendable in this fashion and you could rewrite a new selector engine in JavaScript, then you could have jQuery being a polyfill instead of being a downloadable thing. So what I mean by this is if jQuery was embedded in your browser, then you wouldn't need to make all of those network requests to see if it's already been downloaded from the CDN. When you get a new session, you wouldn't need to download jQuery. jQuery could be implemented in C++ instead of JavaScript and be even faster than it already is. And everything would still just automatically work because if your browser did not support this built-in jQuery, it would just do the old thing of go fetch it because it's a polyfill now. And so that's one example of something that would be super cool if we manage to pull this off. Another thing in terms of actually, so how does this actually lead towards this future UI of the browser eating the operating system? So if the web is a universal like runtime, then we need some sort of notion of applications. And we have this notion of web applications, but we talk about web applications differently than desktop applications. So for example, if we had a little bit of better infrastructure, and this is all being like hashed out right now, Mozilla and Google both have competing proposals, and we are currently arguing over which one of them makes more sense, because that's what we do. Bookmarking a website and like pre-caching all of the assets is very similar to installing an app from the App Store. And in fact, that interface of a home page where you have apps and you click on one and it starts to run could just easily be the same thing. It looks very similar to like web browsers now have like the last 10 sites you visited or whatever, right? But they require a certain degree of like network connectivity because we currently write apps assuming that the web, like the network connection actually works, and we don't have a good way. HTML5 has added a little bit in this, but we don't have a good way to specify, please cache all of these assets for a particularly long time. And we don't have certain other APIs that we would need to truly replace native stuff. But it's getting pretty damn close. I don't know. So normally I would be making this presentation on my Chromebook. So as much as I hate Google, I actually use Chrome OS as my primary OS for everything. And it works pretty damn well. And you'd be surprised when you open a website that's like a Photoshop clone, that's a better Photoshop clone than the GIMP is, obviously. If someone that was not a terminal user was using it, right? I can only call it a Photoshop clone because I'm horrible at Photoshop. But for the purposes of like, cropping out photos and like, squiggling on things and making arrows pointing at dumb things, it totally works. And it's actually all in the browser in JavaScript instead of being a downloadable application. I'm totally drawing a blank on what that's called at the moment, but if you haven't used any of these new like rich JavaScript applications, they're serious business, and they're in many ways like functionally compatible with regular old desktop applications. They're just running in your browser. So as we move more and more towards that future, like I actually even program on my Chromebook because SSHing into a server to use the terminal is the same as using a terminal locally, except for the fact that there's that persistent web connection, right? So, but like other than that, like I actually do everything on stock Chrome OS, and it just works because all my applications are in the browser except for my terminal, and it gives you terminal. So I'm sort of like dog fooding that future right now because I really enjoy it. There's also some other stuff about that I think I have some time to go into, so I will right now. Let me double check. Yeah, before we talk about the implications on traditional web framework stuff, since I have another 15 minutes, I'm going to talk about something that's even more out there interesting that I'm super psyched about. So I've been thinking about this idea, and then I also saw a talk by Gary Bernhardt recently that the video is not out yet, but you should check it out. It's called The Life, Birth, and Death of JavaScript. And we basically independently came to the same idea. So you should, like, for a full half an hour long treatise on this topic, you should go check it out because it's better sourced. But the basic idea is this. If JavaScript is already sandboxed to be safe, then what's the difference between ring 0 and ring 3? For those of you who are not operating systems people, kernel space runs in what's called ring 0, and this is because if you imagine concentric circles of like the innermost area is the most protected, and then an outer ring, and then an outer ring, and outer ring, the further you move up the rings, the less internal details you have, and if you're in ring 0 in the middle, then you have full access. Modern operating systems basically only use ring 0 and ring 3. Historically, 1 and 2 are still there for dumb reasons, but we don't really use them. Sometimes. I'm sure there's something that uses it that I don't know about. But anyway, the point is that calling into kernel space, making a system call, is a very expensive operation. And this is because you need a context switch. You need to like check that if you're even allowed to do this, run this privileged code. And that tends to be things like opening and writing files, which is I/O intensive. And so like the number that Gary had cited from the literature was actually like 30% slowdown making a system call as opposed to a regular call. It's not really important. The point of the part is that it's much, much slower. So if we had, this is also because we expose this non-safe thing to user space. So you have to have this ability to escalate privileges to do certain things because that's like the model we've exposed. If instead you wrote an operating system, there's a kind of operating system that my friends are really into in college called Exokernels. The basic idea is you have a monolithic kernel, then you have a microkernel, and you have an exokernel. So only thing an exokernel does is make sure that two people are not accessing a resource at the same time that they're not allowed to. So like only one process has access to the disk. Only one process has access to the network card. It doesn't do anything else. Like scheduling is in user space. Everything else is in user space. So we could write an exokernel operating system that its only job was to boot up V8. And then you, as a user space developer of this operating system, basically only have access to JavaScript. And asm.js, which if you're not familiar is an amazing project, asm.js would be your assembly code from user space. But now every process is sandboxed and every process is safe, which means we could eliminate the distinction between ring 0 and ring 3, which even though JavaScript is slower than C, it's slower by about the same amount that the calling into system calls is at this point, because V8 is an amazing, wonderful piece of magic. And so it'd probably be roughly about the same. This is also really funny, too, when you think about like one process per tab in a browser. It means that every tab is a process, which is like what you do when you start new programs, right? So it's like kind of funny, too. But this would be the idea that you'd have an operating system that has the web and a web browser as its fundamental component. Instead of you making OpenGL calls, you'd be making WebGL calls, which is basically OpenGL, but like through the web stuff. So you could make all of the existing stuff that you do in 3D. I don't know if you've seen Epic Games has ported the new Unreal Engine to ASM.js, and they don't have a demo you can try yet, but there's a video of the brand new Unreal running in real time in a web browser with full reflection and water effects and like all that crazy stuff that graphics people do. So we have the ability to like make very performant, very real applications, and if we keep going down this path forever, that could theoretically be a future, and that's one I'm interested in making happen. But that only works if we make the web browser extendable enough to actually be a true, safe application runtime for all purposes. OK, so what does this actually mean for people that are doing traditional web development today? This is a little bit Ruby focused. I probably should have taken this off this slide, but whatever. Essentially, in my mind, what's happening in this future is that, so in the Rails world right now, we have this crisis about what to do about JavaScript. It's funny, if you look at the keynotes from RailsConf last year, both of them are about whether or not and how much JavaScript you should use. They're not actually about Rails at all. And I'm not as familiar with other server-side frameworks, but I know that like Python people also are like talking about JavaScript and doing JavaScript-y things. And so there's this weird discussion about like what is the future? Like has Node killed Ruby? Like what are we doing? Like we all kind of use Ruby because we love it. So why are we going to move to JavaScript, which is like frankly a terrible language that's passable once you're good at it, but is like not enjoyable from the Rubyist perspective anyway. And so I think that the future for Rails and other traditional like server-side frameworks is basically you will be an API server only. And that's super cool, and it's super good at that. Like Rails is great as an API server. And basically, most applications now should, if I was writing a Rails app today, I would be using Ember.js primarily as the front end, and I would be using Rails only to serve up JSON for Ember to use. And that sort of feeds into this kind of like concept of your browser is the application runtime. You write your client that runs inside the browser, and then you have back-end services that are obviously super useful, but we sort of have achieved this separation. And I have this last bullet as being admitting reality because I love server-side programming. I don't want to do client-side stuff. So I've put off doing JavaScript for a very long time. But the reality of the situation is that JavaScript is here, and it's here to stay. And we kind of just got to like be adults and not complain about it so much and just like shut up and write some code. Also, one of those keynotes describes the approach of a certain company in the Ruby world that describes you should be using sprinkles of JavaScript and not using any frameworks like Ember that are big and heavy. But their flagship application has a megabyte of JavaScript. So that's like sprinkles of an entire megabyte, right? So there's a little bit of cognitive dissonance there about like we wouldn't use a heavyweight framework like Ember. We just have a thing that's 2 times the size already, So anyway, so that's one of the other things too is that like we as server-side developers need to sort of embrace this future of the web, and it's coming whether or not we like it. So we should be adults, basically. Eat your vegetables. Okay, so. That is web browsers, om nom nom. I am Steve Klabnik. If you want to read more, so I made reference to this, but I forgot to actually say the URL. This future of web browser or web standards being moved is being called the Extensible Web Manifesto, and there are signatories on there from all sorts of important people in the web standards community. There's like Apple and Google and Facebook and a bunch of other companies have like signed on to this Extensible Web Manifesto idea. And so if any of this intrigues you, you should go check it out and hopefully get involved, because I would love to see more of us pay more attention to standards, since they like define our universe. It'd be nice to have some role in defining that universe too, right? So cool. So thank you so much, and I think I have some extra time before my next talk begins. I think I have like 10 minutes of theoretical left talk time, and then I have another talk. So I'll just be up here if you want to ask. If anyone has any questions that would be useful to other people, then feel free to ask them now. Otherwise, you can just come up and we can talk about whatever. So yeah, I guess that's it. So, anybody got questions and stuff? Yes. I am absolutely still talking about Rust, and I'm super jazzed about it next. Yes. What's up?
I know that the big players, talking about the standards, they have a lot of leverage because they are the makers of the browsers.
Right.
They can do pretty much whatever they want.
Mm-hmm.
How are smaller companies trying to leverage that lack of presence in that particular power position?
Sure. So the question is basically, browser vendors are big giant companies with big budgets, and so they have the time and energy to actually, like, a browser vendor can implement whatever they want and kind of force it down our throats to a certain degree, right? So how are smaller companies getting involved in this? So the good and bad thing about the fact that everyone hates Microsoft now is that people are at least vaguely, except for the blind spot when it comes to Google, for all other companies, they sort of are very prepared for them not to become the next Microsoft. And so if you don't work with the standards bodies, people don't like you because they go like, oh, you're being just like Microsoft is. So smaller companies have like 1 or 2 employees or like doing some stuff to put people on the right mailing list to get involved in the discussion. And their proposals are still generally taken seriously because it would appear like big companies are trampling on the small guy, and that's a bad PR scene. So for example, if you recently saw the TIFF about the Shadow DOM, which sounds amazing. I love that name, the Shadow DOM. They're like gonna come and like, it's like a collective of supervillains or something. Google invented this thing called the Shadow DOM, and then they basically like submitted it to the mailing list and was like, hey, we really need to hurry up and rush this thing through the standards process. And everybody was like, hold on, buddy. You need to wait until you get input from everyone, including every single last random person that wants to talk. So I think that culturally, you're right in the sense that there's nothing stopping them from doing whatever they want, but I think culturally we sort of have, there's a degree enough of respect for everyone's voice that even if they're small companies, they can like, have some of their voice heard. Especially if you have a good use case. Like people really respect if you're like, this is bad because reasons, and they're real reasons, and not just like, this is bad, then people are very sympathetic to your arguments. So I'd say that's what's up. I actually personally, there's a guy I know named Dominic, at Dominic on Twitter and everything else, and he actually started complaining about the way that promises were going to work in ES6. And one of the people from the ES6 team was like, hey, sign up to this mailing list and send an email. And now he's like on the W3C technical architecture group and is like helping move all these standards forward, specifically because he like decided to start complaining to the standards authors instead of into the void. And they like took him very seriously, even though he's just some random like unaffiliated freelance person. And he had a big impact on ECMAScript 6. So it can happen. Yes. Yeah.
And then we use JavaScript and manipulate and have everything in the browser. How
Right.
does that work into making the browsers more extensible?
So,
And, and when you talk about ASM, sorry, I didn't.
yeah, no worries.
It seems like you can now take that and extending it into like more native.
So there's a couple questions basically that like, how does extending the browser relate to the standards work, and how does like moving into ASM make it more native? So the first part is basically just that like, acknowledging that the web is no longer a document sharing thing and is now an application platform needs that, like, once we've acknowledged that, we need to make it a better one. And the extensible stuff is the path forward to making it a better one. So it's like not there yet, but this is like what is being worked on to make it be feasible to do these kinds of things. And so, like, for example, you can't really write to the file system from your browser today. There's like some in-memory databases or whatever, but there's not like a, like, write this file to disk. And that's because we have to figure out how to make that API useful and usable and safe. But that needs to be done before you can, like, you know, save your game to something that's not a server, for example. So in the sense of, like, eating the operating system, we need more stuff. In the near term of just like, I'm saving everything on a server somewhere, then like totally that works right now, right? You'd like send a game save state up to your server. But if we wanted to do it entirely local, like remove my network card and play Quake and then save my game, we need to be able to expand what browsers can do more before that's a feasible, like, reality. If that makes any sense. And the ASM stuff does get you down to sort of native in many ways, because, like, you know, it's all JITted in the end somehow, right? Like even so, when I'm running Ruby code, that gets turned into Ruby bytecode, which gets turned into JITted Ruby bytecode, which then gets turned into like assembly at some point, like down the line, right? Or interpreted, I guess, depending on which Ruby you're using. So there's already like a ton of different layers. So ASM just like adds one more. We already have a billion layers, why not add one more? But yeah, you're right, it does get you down to that feeling of like super low level and can translate over really well. So I don't know if that was a great explanation, but I hope that's a little bit helpful. Yes, one more, what's up?
The idea of having a browser that runs in a VA operating system
Yeah.
is pretty interesting.
Yeah.
Prototypes or anybody that is already doing this?
So my friends in college wrote an exokernel operating system, and I was attempting way back in college to actually compile a Ruby VM and basically do this with Ruby back in the day. I just didn't really know like this connection or whatever. So I've been trying to convince them to rewrite the OS in Rust and then port V8 to it so that it will actually work. And I think I got them like part of the way there, but so that's one group of people that's sort of working on this. The second one is actually Mozilla is working on a project called Boot to Gecko that allows you to go from nothing to booting into Gecko, which is their rendering engine, automatically. And I haven't followed that project super closely yet, but I know that they are like actively working on it for things like Firefox OS. And Chrome with Chrome OS is obviously doing something sort of similar. They're just not going, they're building the practical today instead of imagining the far-flung future. So I could see a day where Chrome OS becomes that thing I was talking about, even though it's not it today. So I think that Mozilla and Google are sort of working on it. We'll see how it goes. Just like once they totally give in to the browser, it is just about removing other stuff, right? So Linux has really good driver support, so possibly using Linux is a more practical intermediate solution, even if it's not like a super microkernel thing, just because of the like legacy involved in building up all those drivers, right? Like that's super hard. So we'll see. But yeah, those are the three projects that are like closest to this. Yes.
Seem to be enthusiastic about JavaScript frameworks.
Yeah, sort of.
Can you talk about arguments for people that are against or not too big of a fan?
Sure. So basically, it's like I am super into JavaScript frameworks. What's the reason for that? So the question was like, I seem to be into JavaScript frameworks. What is the argument for using like Ember, for example, over other stuff? So for not using JavaScript at all. So basically, by building a JavaScript first app, your app will be faster. And it will be faster not only in like wall time, but it will be faster in user perceived time, because simply doing the actions and having the update happen instantaneously and then asynchronously sending the data in the background is a snappier interface like constraint in the first place. And then you can do extra like prefetching in the background and loading up of stuff in caches and all kinds of things that you can do because of the flexibility of writing your application in JavaScript first allows you to have. So for example, I really, really actively hate the website bustle.com, which is a magazine for women written by men. It's like a terrible idea. But technically, they're doing amazing things relating to how fast JavaScript first applications can be. And they have like a bunch of blog posts and a whole bunch of stuff about like, here's why our app is super freaking snappy. So that's sort of the argument for JavaScript as opposed to no JavaScript. If you go back to the no JavaScript days, then you're talking like a round trip to the server every time I make any action whatsoever. And that is, you don't realize how much you don't like that workflow until you try to go back to it. So like I was a no script user for like 15 minutes before I was like, nope, everything's just like really terrible this way. But I would say, yeah, like speed and like UI speed as well as like functional speed is most of the reason to do it. I also like the separation of concerns. Like you have one application as your client that does all your UI and stuff, and you have another application that handles persistence and business logic and validating things. It like feels like a cleaner architecture to me than like some other things. But that's more subjective. Cool. Well, thanks everybody.